Coming up on the Children's Hour, we're going out into space with Dr. Katie Mack, Astro Katie. She's the author of the book, The End of Everything, Astrophysically Speaking. Katie Mack is a theoretical astrophysicist, and her current focus is on the timeline of the universe, from its birth and all the way through to its death. Billions of years from now, we're going to explore dark matter, black holes, and so much more. Stick with us for an out-of-this-world Children's Hour. The Children's Hour is kids' public radio produced by the Children's Hour Incorporated, a New Mexico nonprofit. Find out more about us and see pictures and links related to this show at childrenshour.org.
It's time for the Children's Hour, Kids Public Radio.
What do you get when you cross a lamb and a rocket?
I don't know. What?
A space sheep.
It's time for the Children's Hour, Kids Public Radio.
What if the world went backwards, Mum? Would I get up with the setting sun? Dirty my teeth and chew my food? Spit it out whole, would you call that rude? I would grow into a baby, see what I mean? The good thing is my nappy would be suddenly clean after making it smelly in the washing machine. Put in your whites and they come out green. And kitty cat would be tacky tick. Crocodile would be a little cook. Elephant would be the naffy, but Dad would still be Dad. We'd unpaint art, make the canvas bare. Leave the salon with longer hair. Hooray, hip hip when we cheer. Fix your legs when you fall up the stairs. Granddad grows less bald and starts to grin when the dentist puts his teeth back in. He pokes in splinters with a pin and watches his unwrinkling skin. And hippopotamus will be Sumatopope. Kangaroo will be Uraganak. Alligator will be a Rotagilla, but Mum will still be Mum. Toot will still go toot. A kook is still a kook. A dud will be a dud. A nun will be a nun. Wow will still be wow. And lots of laughs will still be lol. What if the world went backwards, Mum? I'd play guitar like. What if the world went backwards, Mum? Would a boat be fun? What if the world went backwards, Mum? Evolution would be fun. Future me with a hairy thumb. A tail much better than a gun. Back in the pond we'd all be scum. What if the world went backwards, Mum? The end of my song would have just begun. If the world went backwards, Mum.
What if the world went backwards? That's Levity Beat right here on the Children's Hour. They're coming out of New Zealand. I'm Katie Stone. I'm so happy to be with all of you out in Listenerland and all these great kids here on Zoom. Hello, everyone.
Hi. Hello.
And who do we have with us today?
Hi, it's Olay.
Hi, it's the olive tree.
Hi, it's Luminata.
Hi, it's Nathaniel.
Hey, it's Gareth.
Hi, it's Evan.
Hello, it's Amadeus.
Hi, friends. It's Melissa.
Well, thank you all so much for being here. We're really going to get spaced out today on the show. We are going to learn about the universe with Dr. Katie Mack. She is an astrophysicist, the author of the book, The End of Everything. And she's going to talk with us about the timeline of the universe, what's out there in the universe outside of our galaxy. And she's got a lot of information about black holes and dark matter. We're going to get into it. It's the Children's Hour. And up next is Ruth and Amelia. Stick with us. This episode is getting out of this world.
Are you ready? Here we go! Ooh, we gonna fly, headed through the starry sky. See the planets sailing by, we're soaring through the galaxy. Gonna bring peace and love, something that's too little love. Share some caring from above, we're soaring through the galaxy.
Four hats on our heads, we got our seatbelts fastened, Milky Way ahead. We're going through, right turn at the moon, and then we're getting closer, we'll be landing soon. So much to do.
Ooh, we gonna fly, headed through the starry sky. See the planets sailing by, we're soaring through the galaxy. Gonna bring peace and love, something that's too little love. Share some caring from above, we're soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Can't believe it's true. I'm so happy that I'm traveling with you. We're flying high, going somewhere new, where we can make a difference. So much we can do when we try. Ooh, we gonna fly, headed through the starry sky. See the planets sailing by, we're soaring through the galaxy. Gonna bring peace and love, something that's too little love. Share some caring from above, we're soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy.
Hey, there's a wormhole up ahead. It's like a shortcut we can take from one point in space to another. Watch out for those black holes, though. Everything gets crushed in there, so we have to avoid those.
Oh no, be careful! Ooh, we gonna fly, headed through the starry sky. See the planets sailing by, we're soaring through the galaxy. Gonna bring peace and love, something that's too little love. Share some caring from above, we're soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy. Soaring through the galaxy, soaring through the galaxy. It's great to be soaring through the galaxy.
You're listening to the Children's Hour, and with us on the show today is Dr. Katie Mack. She's a theoretical astrophysicist. Well, honestly, we have to figure out what that is. And she's the author of a book called The End of Everything. Welcome to the Children's Hour, Dr. Mack.
Thank you very much for having me.
We obviously have to start at square one. What exactly is a theoretical astrophysicist?
Astrophysicist is the word for somebody who studies space and specifically how things in space work. So how stars work, how planets work, how galaxies work, and in my case, how the whole universe works. So I study how the universe started, how it might end, how it's been changing over time, how physics works out there in the cosmos. And the theoretical part, the first part of the name, is because I do this work by looking at theories, at ways that we describe the universe with mathematics, with geometry, with shapes and ideas. I don't use telescopes. I don't look at the sky. I don't use data from observations or experiments. I work on the theoretical side, the side that's really thinking about the ideas, the questions, and the way that we translate what we learn about the universe into mathematics.
Whoa, That leads to a lot of questions, I'm sure, from our crew. Amadeus, I'm going to you.
So, how big is the universe?
That's a great question. So it depends on how you define universe. Okay, so usually when we work with thinking about the universe, we talk about the observable universe. So the observable universe is the part of space that we can see, the part of space that we have any information about. And the universe could be much bigger than that. But just like when you're standing on the Earth, you can only see out to a certain distance. You can see out to the horizon. You can't see all the way around. And it's similar with the universe. There's a kind of horizon, a distance out beyond which we cannot see. And that horizon is about 46 billion light years away. So a light year is the distance that light travels in 1 year. It's a very long way. And just for reference, our nearest star besides the sun is about 4.2 light years away. And that's just within our own galaxy. There's other stars in our galaxy. The closest one is about 4.2 light years away. And so the whole observable universe is, it's a sphere around us of 46 billion light years. Now, it's a sphere because that's how far we can see in every direction. It's not that the whole universe is a sphere. We don't actually know what the shape of space might be if you could look at it from the outside, because we can't. But we know that we can see 46 billion light years in any direction. And so that makes a sort of circle, a sphere around us.
That's so interesting. It's funny because when you think about the universe, I don't know about all of you on the kids crew here. When I think about the universe, I guess I always did kind of think of it like we're in a ball of some kind of stars all around us. But I suppose that makes sense because that's all we can see, really. And that might not actually be the shape or...
Yeah, it's like when you're standing on the Earth and, the horizon is a circle around you, right? Wherever you're standing, there's a circle all around you. That's the horizon. That's as far as you can see in any direction. You can see the same distance in every direction, depending on, maybe there's a mountain or a building. But if you were in a big flat space, you could see the same distance in any direction. That makes a circle centered on you. And in the universe, we're at the center of a sphere centered on us. And that sphere, that ball is 46 billion light years in every direction, because that's how far we can see in every direction. And just, by the way, a light year is about 6 trillion miles. So these are numbers that you can't really keep in your head. I mean, light travels really, really fast. And a year is a long time. So something traveling really fast for a really long time gets very far.
What inspired you to become an astrophysicist?
I was inspired by trying to understand how things work. So when I was a little kid, I used to take things apart a lot. I would disassemble remote controls or little, toy cars, or, try and figure out how my bicycle worked. I was always trying to understand how things worked. And I think that it just kind of kept going from there. I wanted to understand how the bicycle worked, and then I wanted to understand how the physics of a wheel works and how that makes you move forward. And then I wanted to understand how the physics of the Earth works and why we have days and seasons. And then I wanted to understand how the universe works and how physics works out there in space. And, why do we have weight when we're here? And why do the astronauts float around? And all of those big questions. I just wanted to understand how everything worked. And so that naturally led to bigger and bigger questions on bigger and bigger scales. And that's how I ended up thinking about astrophysics.
What is an astrophysicist?
So astrophysics is really just the study of physics out in space, of physics of things out in space. So physics is how things work, how things move, or how things interact, or how things came to be. And astrophysics is that for space. So stars, planets, galaxies, black holes, all of that is astrophysics. And an astrophysicist is somebody who studies those things, who tries to understand them.
The astrophysicist that's with us today on the Children's Hour is a theoretical astrophysicist. Her name is Dr. Katie Mack. And we have so many questions for you, Dr. Mack, because you are doing cutting edge research on things that I'm sure listeners of all ages have no idea even exist. So we're going to come right back with more with Dr. Katie Mack right here on the Children's Hour.
Girls can do anything. Girls are some shining stars. Girls have the right to sing. Don't say we're going too far. Girls can do anything. Girls are some shining stars. Girls have the right to sing. This girl is going too hard. My spaceship is a refrigerator box, covered in foil from the bottom to the top. It's not that sturdy and so it shakes a lot. Number one lady astronaut blasting off. Out in outer space, I can see the woman in the moon's glowing face. The seven sisters waved at me as I flew by. My reply was waving high to the night sky.
Girls can do anything. Girls are some shining stars. Girls have the right to sing. Don't say we're going too far. Girls can do anything. Girls are some shining stars. Girls have the right to sing. This girl is going too far.
I just landed on the red planet. It's dry and abandoned. Look, there's a canyon. I've never been to Mars before. It's the opposite of the ocean floor. It's so hot, it's steaming. I'm thinking about leaving. It's boiling hot from the morning to the evening. I came up here looking for evidence. I have a camera, but no camera lens. I jumped out and started looking for life forms. Right away got blinded by a solar light storm. It looked like the aurora borealis, or a beautiful, shining, magnetic floating palace. I looked at the sky thinking about astronomy, then at the ground thinking about paleontology. So I didn't notice when the aliens followed me. I turned around to see a female alien as tall as me.
Girls can do anything. Girls are some shining stars. Girls have the right to sing. Don't say we're going too far. Girls can do anything. Girls are some shining stars. Girls have the right to sing. This girl is going too far.
A female alien is a Martian girl. There's no evidence of them in the human world. I said to them, I come in peace. They asked their leader, does she have to leave? Their leader said, let's wait till the end of the day. The whole crowd shouted out, hooray! One of them invited me to a party. I told them I will not be tardy. At the party there was music and blue lights. All the female aliens danced and flew kites. I asked them, why are there no boys? We sent them to Pluto, they made too much noise. At the party I had so much fun, but in a while I had to run. I went to my spaceship and flew from Mars. As far as the eye could see were stars.
Girls can do anything. Girls are some shining stars. Girls have the right to sing. Don't say we're going too far. Girls can do anything. Girls are some shining stars. Girls have the right to sing. This girl is going too far. Girls can do anything. Girls have the right to sing. Girls can do anything. Girls have the right to sing. 5, 4, 3, 2, 1, blast off. Another rocket ship run. Another rocket ship run. Another rocket ship run. Five, 4, 3, 2, 1, blast off. 5, 4, 3, 2, 1, blast off. Another rocket ship run. Take me to the moon. 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 When I get there, I go dancing through the air. When I get there, I go dancing through the air. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1, blast off. Another rocket ship run.
You're listening to the Children's Hour, Kids Public Radio. We'll be right back.
The Children's Hour is produced by the Children's Hour Incorporated. We're a New Mexico-based nonprofit organization supported by listeners just like you. Learn more about us at childrenshour.org. Museum of Indian Arts and Culture and Museum of International Folk Art, divisions of the New Mexico Department of Cultural Affairs, support the Children's Hour. Learn more about both museums at newmexicoculture.org/museums. Support for the Children's Hour is provided by Electric Playhouse. Learn more at electricplayhouse.com.
I've been asked to say a few words to Earth people about the stars. You see, I've been there. I came from the planet Vulcan. For centuries, you Earthlings have been starstruck. You've had your lucky star. You kiss when you see the first star at night. You have movie stars, and you wish upon a star. Have you considered the possibility that on a star, the star people wish upon an Earth? For example, Earthlight, Earthbright, First Earth I see tonight. Or Twinkle, twinkle, little Earth, how I wonder what you're worth. Sounds strange? Well, on Cestus Omicron 3, the all-time hit song is Earth Dust. Also, people will sing Catch a Falling Earth and put it in your pocket. And might you not have difficulty accepting the idea of a national anthem called the Earth Spangled Banner? You see, it is, after all, a question of point of view. If I were an emotional creature, I would be shocked by your Earth concept of stars falling on Alabama. Really, I find that most illogical. Now, as to the matter of space sanitation, will you take a moment to consider all the littering and debris my planet has to contend with? Old nose cones, cameras, and even a corned beef sandwich, and those rocket fumes. On Vulcan, our leader's wife has started a Let's Keep Space Beautiful campaign. And now, I must hurry off to a galactic convention of what you Earth people might call those little green people. I leave you with the good advice my father gave me when I left my home planet Vulcan. Don't let the Earth get in your eyes.
That's Leonard Nimoy as Spock. And Spock, just for people who don't know, he's a character in Star Trek who is a Vulcan, which is a person from another planet who's still inside our universe. Over the break, you heard Spontic, and before that was Laurie Berkner from the Dance Remixes CD. And from the compilation Science Fair, you heard MC Fireworks with Secret Agent 23 Skidoo, the song Rocket Science. You're listening to the Children's Hour. Today we are with Dr. Katie Mack. She is a theoretical astrophysicist. That means she studies the way the universe and space all works. And theoretical, she's thinking about the math involved, which is such an interesting thing in and of itself, Dr. Mack. Like the math we learn in school right now can describe things like black holes. How?
It's really about how we talk about what we observe. So when we see something happen in the universe, we can write down our observations. We can write down what it is that happened. And so, for example, if you drop something, you could write down how far above the ground it was when you let go. And you can write down how long it took before it hit the ground. And you can do that with several different heights, several different objects. You can raise something up really high and see how long it takes. You can drop something from lower. You can put it on a ramp and see how long it takes to roll down. And that gives you numbers, that gives you data that you can then work with. And you can say, well, maybe I can put together an equation that says if I raise the ball up this high and drop it, it'll take this long to reach the ground. And if we raise it up this high, it'll take this long to reach the ground. And that's really all of how we do physics in all different ways. When we look at how the moon orbits the Earth, the moon goes around the Earth in about 28 days, and we can write an equation for how long it takes to go around. That's what theoretical physics is all about. And sometimes we take those numbers and we put them in computers, and then we make a computer model. Just like if you play a video game, you might see in the video game that if you move your character forward a little bit and make it jump, it'll follow a certain path. It'll kind of do something related to what you put in when you put in the video game. And that's creating a model of the world in a computer. And you can, manipulate it. And we do that in physics. We create a model of the universe in a computer. We, put together sort of like a computer game where there's, for example, a sun and then planets orbiting the sun, and we can change the speed of the planet and see how that changes, how it goes around the sun. Those kinds of things are what we work with all the time. And so we can do that with equations, we can do that with computer models, we can do it with looking at patterns and shapes. And that's what theory is all about, is finding those kinds of patterns.
The universe is so big, but I hear a lot of it is full of a thing called dark matter. What exactly is dark matter?
Well, that's a great question, because dark matter is the thing that I spend most of my time thinking about in my research. Matter is a word we use for anything that is really just anything that's stuff. It has weight, it has mass. So, if you pick something up and you drop it and it falls to the ground, that's something that's matter. It has mass. It has mass is just a kind of word for weight in terms of how much stuff is in something. And most matter is the kind of stuff that you can see and touch, like stone or even air is a kind of matter that even though you can't see it and you can't really touch it in the way we can touch other things, you can, wave it around and it has effects that you can experience, like when it's windy. Dark matter, it seems to be something different. So it's a kind of matter. So it has mass, it has gravity, but it doesn't seem like we can see or touch it at all. The reason that we think it's out there in the universe is because the gravity that it has affects how things move around in the universe. So in some cases, we see things moving around in a way that suggests that there's more stuff there than what we can see. There's more stuff there with mass, with gravity, than what we can see. It's something else that has weird properties that seems to kind of move right through other matter, but it still has weight. That's what dark matter is. We're not certain about anything with dark matter. We don't know what it's made of. We don't even know for certain that it's out there, although that seems to be the best explanation for what we observe, for how things are moving around in the universe. And so we're trying to figure out what it is. And that's part of what my job is trying to figure out what dark matter is, because it seems like most of the matter in the universe is this invisible stuff. Something like 85% of the matter in the universe seems to be this invisible stuff. And the things we can see, the stars and galaxies, are just kind of moving around in response to all the dark matter that's there. But the dark matter is most of it.
What about black holes? Couldn't they just be like big black holes of dark matter?
That's a good question. I actually just recently worked with some colleagues to write a paper about the possibility of black holes being dark matter. But the kind of black holes you would need to be the dark matter would be really, really little ones, very different from the kind that we think of when we think of a black hole as something big out there that's pulling in matter and stuff like that. So there are different kinds of black holes. The kinds of black holes that we talk about that we know are out there are black holes that form when a star dies. So, stars are shining because they're doing nuclear reactions in the center. So they're converting different kinds of atoms to other kinds of atoms. And that process creates light. So all stars are shining because of that. And when a star finishes converting all of the material into the other kind of material, then it doesn't have anything else to be shining, and then it starts to fall toward itself. It starts to collapse. And there are different things that can happen at that point. And if it's a really massive star, much more massive than our sun, then when it falls together, when it collapses, it can sometimes collapse into a black hole. And what a black hole is, it's kind of if all of the matter is coming together and there's so much of it and it's so heavy that nothing can hold it out anymore. And it collapses together so tiny that it becomes the smallest possible thing you can think of. And that's a black hole. And it kind of changes the space around it. And it becomes this really weird, really cool kind of object. Now, we have a lot of ways to understand the existence of black holes. We're pretty sure that they're out there. We're very sure that they're out there. And one reason is because although we can't see the light that goes into black holes, because one of the key things about black holes is that nothing can come out of them. So we can't see the stuff going in, but we can't see the stuff inside the black hole, but we can see that things are falling into the black hole. So sometimes there's gas or dust or even stars really close to a black hole, and those will sort of go around like they're in a whirlpool. So if you've ever seen like a whirlpool, or even just like if you have a bath and you take the plug out of the bath, the water is mostly transparent, but you can see it when it swirls around because it kind of crashes against each other, gets bubbly. And it's like that with matter falling into black holes, with gas or stars falling into black holes. And so we see that shining of the stuff that's falling into black holes. And that's one of the ways that we find black holes, that we know they're out there, is because we see stuff falling into them. And then we also see that they disturb space when they fall into each other. So two black holes sometimes collide with each other, and that causes ripples in space called gravitational waves. And we can pick those up as well.
Wow, I am learning a lot from you, and I hope you are too, listeners. This is Dr. Katie Mack. She's also known as Astro Katie. We've got a lot of links and more posted at childrenshour.org. Look for this episode called The Universe, and we're going to be right back with more.
Rainbow sparkling galaxy shimmers in the moonlight.
This is Jackie B and the Mini Band.
1,000 universes shining bright. I'm dancing with the stars. I'm flying very fast. I'm flying next to Mars. Do 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 do. I see a shooting star. Shooting star. It's flying very fast. To make my wishes come true. My wishes come true. For me and you. Stardust starts a new generation. 1,000 universes united under one. I'm dancing with the stars. I'm flying very fast. I'm flying next to Mars. Do 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 do. I see a shooting star. Shooting star. It's flying very fast. Very fast. To make my wishes come true. My wishes come true. For me and you. Who knows, there might be aliens around here. Around here. I see a shooting star. It's flying very fast. To make my wishes come true. My wishes come true. For me and you. I see a shooting star. Shooting star. It's flying very fast. Very fast. To make my wishes come true. My wishes come true. For me and you. I see a shooting star. Shooting star. It's flying very fast.
You're listening to the Children's Hour. I'm Katie Stone, and we have with us today on the show Dr. Katie Mack. She's a theoretical astrophysicist, and she also has an expertise in a unique area, the timeline of the universe. We have known with math and physics how to calculate the beginning of the universe. Scientists generally agree it's around 13.8 billion years ago, but Dr. Mack's emphasis is on extending the math the other direction, forward, to what happens as the universe ages. Using the principles of physics that we understand today, there are many theories as to how the universe ends. But spoiler alert, it's billions and billions and billions and billions of years away from today. One thought is that the universe just keeps on expanding and expanding forever until we are all isolated in a dark, dark universe. Another theory is that we continue to expand and expand as a universe until we eventually reach some sort of an end. And then the universe will start collapsing backwards. These are all theories, but all of these theories are based on the math and the physics and the science that we understand today that seems to be proving other things to be true about the universe. Dr. Katie Mack explores all of this in her book, The End of Everything, Astrophysically Speaking. Dr. Katie Mack is our guest, and we're going to be back with her in just a minute. Coming up next, this is Kathy Fink and Marcy Markser, right here on the Children's Hour.
Wouldn't it be heavenly to know the constellations? Scan the skies and recognize their names and their locations, though they're only figments of our own imaginations. Wouldn't it be heavenly to know the constellations? Hercules, Delphinus, and Andromeda, and Lyra, Sagitta, and Pegasus, Dorado, and Lacerta, Ursa Major, Ursa Minor, Cetus, and Orion. I could name a dozen more if I were really trying. In the zodiac you'll find a dozen constellations. You can trace them in the sky with just a little patience. Leo, Virgo, Scorpius, and Gemini, and Taurus. These are 5, now who can name the other 7 for us? Aries, Libra, Sagittarius, Cancer, Pisces, Capricorn, Aquarius. Determines what we see among the constellations. Atmosphere, the time of year, as well as their locations. Latitude and time of night are prime considerations. Each of them are factors when we see the constellations.
Past quasars and pulsars and black holes I blew, past galaxies far, far away. In a rocket as rapid as lightning I flew, for 91 years to the day. I ripped past Orion, the nebula's eye, ignoring the aliens' laughter, ha ha ha. My beard had grown down to my ankles when I arrived at the place I was after. The edge of the universe, lined with a curve, and a street paved with bricks and with mortar. The signs on the houses read, "Do not disturb," and the meters all blinked out of order. So I sailed back to Earth and got younger and thinner. My beard disappeared to mere fuzz. I walked in my house just in time for my dinner. And no one believed where I was.
You're listening to the Children's Hour, and that was poetry by Mike and the Mighty Magic Pants. Kathy Fink and Marcy Markser before that, The Constellation Jig. In the background, Space by Samite. You're listening to the Children's Hour. Today we're learning about the universe with Dr. Katie Mack, a theoretical physicist. We've got links and a lot more posted. Visit us at childrenshour.org. Look for this episode, The Universe.
You're listening to the Children's Hour Kids Public Radio. We'll be right back.
Thanks to the Outpost Performance Space in Albuquerque, New Mexico for hosting the Children's Hour. Support for the Children's Hour is provided by United Way of North Central New Mexico. Support provided by the City of Albuquerque and the Urban Enhancement Trust Fund. Support for the Children's Hour provided by the County of Bernalillo, New Mexico. Many thanks to the users at tokenibis.org who direct funds to the Children's Hour every week. Keep up with the Children's Hour and subscribe to our monthly newsletter at childrenshour.org. You're listening to the Children's Hour, and I'm Katie Stone. And today on the show, we're thinking about our universe. Dr. Katie Mack is with us. She's a theoretical astrophysicist. The kids have a lot more questions for you, Dr. Mack.
I heard about the rippling of space-time. What is it?
One of the ways we think about gravity, and we think about gravity this way because of Einstein, because Einstein taught us to think about gravity this way.
The legendary physicist, Dr. Albert Einstein, that is.
We think about gravity not as a force, really, but as the shape of space. So I don't know if you've ever seen this thing where, like, you have a trampoline and you put a bowling ball in the center of a trampoline, and then you can roll other balls around and they sort of go orbit around because they're moving around because the trampoline is bent in the middle. So that's kind of like what's happening in space, but it's different because space is three-dimensional and the trampoline is just a surface. So there's kind of this weird way in which space is this like fabric that can bend and stretch and move around. And we don't usually think about it that way because we just exist out here and we don't experience space as an object, but it does have properties. It can bend and stretch and move in different ways. So it turns out that when massive objects in space, like black holes or stars, are moving around in a certain way, they can bend space and cause these like ripples to go out through space away from them. And they distort the space around them and they make it move and they make it sort of bounce around. And we have experiments that we can do here on Earth that can kind of feel that vibration of space. So just like scientists can feel the vibration of the Earth with seismographs, and they can tell that there was an earthquake far away, we can feel how space is moving when black holes collide with each other. And we've detected that several times, gravitational waves, these waves in space from massive objects moving around, like spiraling in together.
Is it almost like when you hear a really loud sound that's super far away and it kind of comes, it almost comes to you in waves? Is it kind of like sound waves in a way? Like, have you noticed things like that same pattern over and over again? Like the ocean has waves, and then there's sound waves, and there seems to be a desire for things to do that wavy shape in nature.
Yeah, it's a slightly different kind of wave than a sound wave because what it's actually doing is kind of stretching and squeezing space instead of sort of pushing it backward and forward. So it's a different shape. But yeah, I mean, waves are a way that things move from one place to another, that really information moves, which is a complicated subject, but it's how you transmit things from one place to another, how something moves from one place to another. I mean, an ocean wave is not the water moving from one place to another. It's kind of the height of the water moving from one place to another in some way. And with space, it's kind of a similar thing where it's not the space moving, but it's something about the space that's moving, and that goes through as a wave. And that's kind of a constant thing in the universe, that light is a kind of wave. In some ways, particles are waves. It gets very deep, very complicated very quickly. But space can have its own waves in it with gravity.
Wow. I never even really thought of all that, which is what's so great. theoretical physicist Dr. Katie Mack gets us thinking about the universe. You can find links and pictures and more info at childrenshour.org. Look for this episode, The Universe. Dr. Mack, thank you so much for being with us on the Children's Hour today.
It was really fun, and thanks for all the great questions.
Bye. Goodbye.
This is Randy Kaplan right here on the Children's Hour.
In a race to the star, next stop is Mars.
Oh, Mr. Spaceman, you sure have started something. Oh, Mr. Spaceman, don't you know you got his heart a-thumping? Oh, Mr. Spaceman, my kid, he wants to be a spaceman too. My boy. Oh, Mr. Spaceman, Mars is the new norm, but it's gonna be terrible until it's terraformed. Oh, Mr. Spaceman, I heard Venus ain't half bad. Sure, we'd have to float 30 miles high so the atmospheric pressure wouldn't crush us. Then there's the sulfuric acid rain and the complete absence of molecular oxygen. Bit closer to home though, isn't it? 25 million miles? That's nothing. It's half the distance to Mars. That giant Jupiter's got more moons than it needs. Callisto, Europa, Io, and Ganymede, like 65 other ones. How come they don't all collide? I'd ask Carl Sagan if I could. He was my best friend's grandmother's cousin by marriage. We can't live on a gas giant anyway. I know that. Everyone does. Especially one that's 400 million miles away. Hey, how about Mercury? Its axis has no tilt. I understand it's not too hot in the polar regions. What? 57 million miles away? That's further than Mars. Forget it. Cross it off the list. My kid talks about spaceman from dawn to dusk. I say get off my case, man. Go talk to Elon Musk. He's Mr. Spaceman. Just click the careers link on the SpaceX site. You could be an intern there. One small step for a boy, one giant leap for a boy's mind.
I forgot my cookie.
Oh, Mr. Spaceman, you sure have started something. Oh, Mr. Spaceman, certainly got my heart a-thumping. Oh, Mr. Spaceman, my boy wants to be a spaceman too. Yodelay, yodelay, ooh, yodelay, ooh, yodelay. Stick around down here, son, we can yodel together. Listen to Jimmy Rogers and stuff. I'd be pretty broken up if you left for the red planet. My mom, your Mima, she was upset enough when I left for California. And you should have seen her mom, my Nana, when Uncle Bruce left for Japan. Oh, she nearly lost her marbles. Oh, Mr. Spaceman, he hates his car seat, so when we go anywhere,
I don't wanna go.
He doesn't wanna go. Oh, Mr. Spaceman, 50 million miles is a bit too far. Okay, boy, you know how we drive upstate to Charlevoix every summer? That's 250 miles. Takes about 4 hours, right?
Yeah, Daddy.
So 500 miles, 8 hours round trip without stops, right? You following me?
Yeah, I'm following.
Going to Mars would be like going back and forth to Charlevoix 100,000 times. That's one round trip every day for about 275 years. All right, I know the spaceship goes a little faster than my car. But even so, unless they got some sort of cryogenic freeze available, I can't imagine you sitting there for that long. And even if they did have cryogenic suspension, I'm not sure that would appeal to you either. We have enough trouble with you at bedtime now. Just imagine you and the commander saying, okay, time to go into cryogenic freeze, and you, I don't want to go to hypersleep. Right? Well, he might not be as lenient as Mommy and me. You never know.
It's time for outer space poetry. Outer space poetry. It's time for outer space poetry. That's right, I'm calling Houston. Houston's picking up. Houston saying go, go, go with your outer space poetry.
Space by Kristen Nichols. Something mysterious calling to me, much farther than the eye can see. I look up to the sky in the middle of the night and think to myself, what a wonderful sight. I know that someday I'll be traveling there, a certain place with an extreme lack of air. I have a taste for adventure, and soon I will be in space, the place that is waiting for me. A wide open area like a big sea of black, something exciting, and that's a true fact. It holds stars that we see in the late night sky, but without a rocket ship, it's unbearably high. Although this wonder is extremely dark, to people like me, it's a great work of art. It's filled with galaxies, more than two. Space could be fun, especially with you.
Davy Crockett, traveling through outer space. Reborn in the stratosphere and Saturn bound, flying fast and miles off the ground. Jumped from the spaceship just to look around and shot off his gun without making a sound. Davy Crockett, king of this brand new place. Davy Crockett, traveling through outer space. Off went his rocket at the speed of light, flying so fast there was no day or night. Messing around with the fabric of time, he knows who's guilty for there's even a crime. Davy Crockett, the buckskin astronaut. Davy Crockett, there's more than we were taught. Hiding in the cargo was a robot drone, programmed to destroy Davy's spaceship home. Davy switched out his brains, now the drone's a dog clone. Named him Copernicus and threw him a bone. Davy Crockett, king of this brand new place. Davy Crockett, traveling through outer space. Davy Crockett, king of this brand new place. Davy Crockett, traveling through outer space.
That was They Might Be Giants right here on the Children's Hour. Before that, Sarah Hickman from her Big Kid release with Space Poetry. We've been doing a show today about the universe with Dr. Katie Mack. You can catch a TED Talk with Dr. Mack where she talks about her joy, really, discovering what might be the end of the universe. It's a pretty interesting talk. It's linked at childrenshour.org. Look for this episode, The Universe. Speaking of our website, childrenshour.org, you can find hundreds of podcasts there. All you have to do is click on the podcast menu item, and there they are. You can grab them and take them with you for road trips. We hear they're a lot of fun in the car. Maybe that's how you're listening right now. And we have time for just one more from Down in the Backpack. This is Bill Harley.
We all live in the Milky Way. The Milky Way's our galaxy. We all live in the Milky Way. It's home to you and me. And in that galaxy there's a star, a fine star called the sun. Star in the middle of a galaxy that's home to you and me. Sing it with me now. We all live in the Milky Way. The Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. Around that star a planet spins, a fine planet, the planet Earth. Planet round a star, star in the middle of a galaxy that's home to you and me. We all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, there's a land, fine land, very fine land. Land by the sea, sea on the planet, planet around a star, star in the middle of a galaxy that's home to you and me. We all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. And in that land there's a town, fine town, a very fine town. Town in the land, land by the sea, sea on the planet, planet around a star, star in the middle of a galaxy that's home to you and me. We all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. Take it away! In that town, there's a street, a fine street, very fine street. Street in the town, town in the land, land by the sea, sea on the planet, planet around a star, star in the middle of a galaxy that's home to you and me. Hey, we all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. On that street, there's a house, a fine house, your house. House in the street, street in the town, town in the land, land by the sea, sea on the planet, planet around a star, star in the middle of a galaxy that's home to you and me. Hey, we all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. And in that house, there's a person, a fine person, that's you. You in the house, house on the street, street in the town, town in the land, land by the sea, sea on the planet, planet around a star, star in the middle of a galaxy that's home to you and me. Last time! We all live in the Milky Way, the Milky Way's our galaxy. We all live in the Milky Way, it's home to you and me. Take it away!
The Children's Hour is produced by the Children's Hour Incorporated, a New Mexico nonprofit.
You can find photos, links, learn-along guides, and more about us at childrenshour.org.
Today's show was written and produced by me, Katie Stone, along with help from our senior producer, Christina Stella. We also had help this week from our intern, Daniel.
Find our podcast wherever you listen to podcasts, or go to our patreon.com/The Children's Hour.
Or ask your smart speaker to play the Children's Hour podcast.
We post our photos and more on Instagram and Facebook. Find us at TCH Radio.
Our theme music was written by C.K. Barlow.
The Children's Hour is distributed by Native Voice One, the Native American Radio Network.
Thanks for listening to the Children's Hour, Kids Public Radio.